Hi everyone. In today's lesson, our first one from Unit 6, we'll be taking a look at how to simplify radicals. So you may have covered a little bit of this in Algebra 1, but before we talk about radicals, we have to talk about numbers that are perfect squares. A perfect square is defined as a number that can be expressed as the product of two identical factors. For example, 4 is a perfect square since it can be written as 2 times 2. So in the table below, we're actually going to make a table of perfect squares that you want to keep handy to use as a reference as we go through this lesson. So notice in the table, my first number was 1, and then 1 squared would give me 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 times 5 gives us 25, our next perfect square. 6 squared is 36, 7 squared is 49, 8 squared is 64, and so on. And you can use your calculator to help you out if you don't remember some of your facts. Okay, so remember that a perfect square is called that because if you have a square with all 4 angles being right angles and all 4 sides being congruent, the area of that square would be found by taking the length of one side times the other. 2 times 2 gives us 4. So that's why it's called a perfect square. So next we'll take a look at how to simplify radicals. Now sometimes you get lucky, like in the first one, where we have just the square root of 9. And if you go back to your list of perfect squares, we know that 9 is on that list of perfect squares. So you can go ahead and take the square root of 9 just by simply knowing that 9 is 3 times 3. So the square root of 9 is just 3. So when you're doing problems like this, the first thing that you want to do is see if you do get lucky and you have a perfect square. For example, number 2, we have the square root of 25, which is just 5. And you can use your calculator to help you out with this as well, and I'll be showing you how to do that in class. Jump down to number 5. The square root of 81 is just 9, because 9 times 9 gives us 81. Now with the rest of these, you have a little bit of work to do. Okay, in our example, we have the square root of 32. So if you try to take the square root of 32 in the calculator, it gives you the decimal. So that means you have to take a different approach. And you want to use your list of perfect squares. And again, those numbers were 4, 9, 16, 25, 36, 49, 64, 81, sorry about that, 100, 121, 144, just to get started. Okay, you want to find the largest number on that list that divides into 32. And while I know 4 works, we want to go bigger. And if 4 divides into your number, you then want to try 16. So notice that I've rewritten 32 as 16 times 2. And the square root of 16 gives me a 4 outside. And we're left with a 2 on the inside. So that's, again, in simplest radical form. We can't do anything else to it to make it simpler. So jump down to number 3 with me, and it's the square root of 75. So if I take a look at my list, the first number that I come across that I think will divide into 75 is 25. So rewrite the square root of 75 as 25 times 3. And I'm usually in the habit of circling my perfect squares. So the square root of 25 gives me 5 on the outside, and we're left with 3 on the inside. So 5 square root of 3 is our final answer. Okay, and number 4, we have the square root of 27. And if we notice, 27 is not on our list of perfect squares up here. So we want to find a number on the list that divides into 27. So now 4 doesn't go into 27 evenly, so I come here to 9. So we want to factor 27 into 9 times 3. 9 is our perfect square, and when we take the square root of 9, we get 3 on the outside but this 3 stays inside the radical. So our final answer is 3 square root of 3. Okay, jump down to number 6. The number is 125, the square root of 125. And 125, like 75, can be divided by 25. So rewrite 125 as 25 times 5. And we want to take the square root of 25. So the square root of 25 brings a 5 out. We're left with a 5 inside the radical sign. Okay, with the square root of 96, 4 would definitely divide into 96. And we want to go bigger. So remember what I said, if 4 works, try 16. I'm going to go for the biggest perfect square. It'll be less work if you find the largest perfect square. So 16 does divide into 96 a total of 6 times. So 16 times 6 is 96. 16 is our perfect square. That means we can take the square root of it and get a whole number. And the square root of 16 will give us 4. And then we're left with the 6 inside the radical. So our final answer is 4 square root of 6. Okay, with number 8, we've got the square root of 288. So it's a big number, and there are lots of numbers on this list that divide into it. But what I notice is 288 is just 2 times 144. So it's not a bad idea just to try dividing an even number by 2 to see what's left. So 144 is equal to 12 squared. So the square root of 144 gives us 12 on the outside. So square root of 144 gives us 12 on the outside, and we're left with 2 on the inside. Okay, so the next step in simplifying radicals is figuring out what to do if you have a number outside the radical. So if you take a look at this example, 3 square root of 12, we have to simplify the square root of 12 because there's a perfect square that divides into 12. So when we do simplify it, we're going to multiply the 3 by whatever we take out of the radical. So notice that with the square root of 12, like I mentioned, there's a perfect square that divides into it, and that's 4. So I've rewritten the 12 as 4 times 3. When I take the square root of 4, I get a 2, and it comes out in front, and notice that it gets multiplied by the 3 that was already out here. And that's because this is 3 times the square root of 12, so it's 3 times whatever you bring out of the square root of 12. And when you do 3 times 2, you get 6 square root of 3 for your final answer. Okay, so the first example we have here, number 9, is pretty easy because 16 is a perfect square. And I'll switch up the color here. So we have 8 times the square root of 16. Well, the square root of 16 is just 4 because that's a perfect square. 8 times 4 gives us 32. Final answer. And number 6, we're not lucky. We don't have a perfect square. So we're going to rewrite this as 6 times the square root of 4 times 6. Because 4 is the biggest perfect square that divides into 24. Okay, so remember the 6 out in front gets multiplied by whatever you bring out, and the square root of 4 gives you 2, and we're left with a 6 on the inside. Final answer, take and multiply the 6 times 2, you get 12 square root of 6. Okay, in number 11, we have 3 times the square root of 32. If you remember earlier, we had the square root of 32 as a problem. And 32 can be factored into 16 times 2. So we have 3. It's going to get multiplied by the square root of 16, which is 4. So that comes out of the radical. And this little 2 stays inside. So final answer will be 12 square root of 2. Okay, radicals have a lot of rules, and the next rule involves adding and subtracting. Before you can add or subtract radicals, you must have like terms. This means that you need the same number inside the radical. If you take a look at my example, we have the square root of 12 minus the square root of 27. Different numbers inside the radical. So notice that we're going to simplify each of them first. The square root of 12 factors into 4 times 3, and the square root of 27 factors into the square root of 9 times 3. That square root of 4 is going to become a 2 out in front, times the square root of 3. The square root of 9 is 3, that goes out in front, times the square root of 3. And now you have like terms. Now in this case, the radical kind of acts like a variable would. If you had 2x minus 3x, you know you'd have negative 1x. So notice that the radical doesn't change, just like the x doesn't change when we're doing addition and subtraction. So this means we have 2 square roots of 3 minus 3 square roots of 3. So we have negative 1 square root of 3 as our final answer. Okay, this first one, number 12, it's already set up for us as like radicals. They both have the square root of 2, so we can go ahead and subtract. So you want to take 5 square root of 2 minus 2 square root of 2. So just subtract those coefficients to get 3 square root of 2. And that's it. Number 13, not so lucky. We have to simplify first. And again, we've seen the square root of 32 before. You probably have this one memorized. 32 factors into 16 times 2. And then we have plus the square root of 8. Well, 8 factors into 4 times 2. So here's another tip. If you use 2 inside the first radical, the second radical hopefully will have a 2 as well, so that they can be like terms. So see what you get when you divide that second number by 2. In the first radical, the square root of 16 gives us 4 on the outside, with the square root of 2, plus the square root of 4 gives us 2 square root of 2, and now you have like radicals that you can add together. 4 square root of 2 plus 2 square root of 2 is 6 square root of 2. Final answer. Okay, and number 14, we have the square root of 60 minus 15. I know that 15 is only 5 times 3 or 1 times 15, and that means that we don't have a perfect square that divides into 15 that's going to help us simplify it. So that's kind of a clue for us that when we simplify the square root of 60, we want to end up with 15. So if you check it out on your calculator, if you divide 60 by 15, you're going to find that it goes into 64 times. And that gives us a perfect square that we can simplify. Again, that square root of 15 on the right can't be simplified. So the square root of 4 gives us 2. We're left with the 15 inside the radical. And then we're subtracting the square root of 15. So if it helps, put a 1 out in front, because you have just 1 times the square root of 15 there. These guys are like terms. 2 square root of 15 minus 1 square root of 15 is 1 square root of 15. And it's totally fine if you just want to write your answer as the square root of 15. Okay, with multiplying radicals, you can simplify the radicals first and then multiply, or you can multiply first and then simplify. So if you check out my example, I did the square root of 3 times the square root of 8, which means you can write it as the square root of 3 times 8. 3 times 8 is 24. That factors into 4 times 6, with 4 being a perfect square. And then the square root of 4 gives you 2. So 2 square root of 6, final answer. In the second case, I chose to simplify the square root of 8 first. So I factored 8 into 4 times 2. Took the square root of 4 to get a 2 outside the radical. And that 2 is going to stay out in front. And then you're going to multiply the square root of 3 times the square root of 2. And that becomes the square root of 6. So no matter which way you do that, you end up with 2 square root of 6 as your final answer. Okay. So I think most students choose to multiply first. So if you take the square root of 12 times the square root of 8, that's equal to the square root of 12 times 8. And 12 times 8 is 96. And you might recall that we did this one before. So if you look back, you can see that 96 factors into 16 times 6. And the square root of 16 gives you 4. Square root of 6. Final answer. And number 16, we have the square root of 15 times 10. So we're going to take 15 times 10. We get the square root of 150. And notice that 150 is divisible by 25. So 25 goes into 150 6 times. So the square root of 25 gives us 5. We have a 6 left inside. Okay, when you're dividing radicals, you can choose to rewrite it as one big fraction underneath. So 128 divided by 8. Just like I did up here, I wrote it as a fraction underneath the radical. 8 divided by 2 gave me 4, and 4 is a perfect square, so the square root of 4 is 2. So if we take and divide 128 by 8 in this case, it's going to go into it 16 times. And then the square root of 16 is just 4. Now, we have two cases where we had just a whole number for the answer. It's not always going to work out that way. Okay, it just happens to be the examples that I've set up for you have worked out that way. Okay, number 18, we write this as the square root of 72 over 2, fraction inside the radical. 72 divided by 2 is going to give us 36. It's still inside the square root. And the square root of 36 is 6. Okay, so I'm just going to throw another example out there. If we had the square root of, say, 24 divided by the square root of 2, you could rewrite it as 24 over 2 inside the radical, which would be the square root of 12. And notice that that has to be simplified. So we'd factor 12 into 4 times 3. And the square root of 4 gives you 2. So 2 square root of 3 would be your final answer for that. That was just a little extra one so that you could see one where it wasn't just a whole number for the answer. Okay, when you're working with radicals, there are a lot of rules to follow. And one of our rules is that we're not allowed to have a square root or a radical sign in the denominator. So what we do is something called rationalizing the denominator. If you take a look at my example, 3 over the square root of 2, the problem with that is that there's a square root of 2 in the denominator. So I have to rationalize. So I multiply both the numerator and the denominator, top and bottom, by the square root of 2. In the top, it just becomes 3 square root of 2. In the bottom, the square root of 2 times the square root of 2 gives us the square root of 4, which happens to be 2. It's a perfect square. The top can't be simplified. It's just 3 square root of 2. The bottom is now a 2. And this is what's referred to as simplest radical form. Okay, so we have no radical in the denominator. Okay, so if you take a look at number 19, we have 4 over the square root of 8. We want to multiply the numerator and the denominator by a number that will make this a perfect square down here. Now certainly I could multiply by the square root of 8 because that would make it the square root of 64, but I want to show you something a little different. Instead of just multiplying by the number itself, try multiplying by something that will make it a perfect square without giving you something that you have to simplify later. So the square root of 8 times the square root of 2 is the square root of 16. And in the numerator, that would be 4 square root of 2. So now we have 4 square root of 2 all over 4, because the square root of 16 is 4. And we notice that right here, we can simplify. 4 divided by 4 is 1. So in the end, we're left with 1 square root of 2 over 1. You don't need to write those ones. The final answer would just be the square root of 2. Now number 20, the best thing to multiply by in this case is the square root of 6. That's the smallest number that will make this a perfect square in the denominator. So in the bottom, square root of 6 times the square root of 6 is the square root of 36. In the top, we have 6 square root of 6. So keep simplifying. The square square root of 36 is 6, and then you can reduce. 6 divided by 6 is 1. So we just get 1 square root of 6, or square root of 6 is your final answer. Okay, so good luck on the homework. This is going to take lots of practice before you can do it quickly. So make sure you do every single problem on the homework.